Hello, algebra students. This is day 2 of solving systems of linear equations by elimination. And we're going to be looking at some problems that require us to do a little bit more work. Specifically, we're going to have to multiply both equations by something so that when we add them together, one of the variables goes away. So look at this first one. If we just look at the first equation and we try to find something to multiply by it to make a variable cancel out when we add to the second equation, there's just nothing that will work, right? We could multiply by 2, we would get 6x, but we wouldn't get 5x. Nothing is convenient. Same thing when you look at the bottom equation. You can't multiply it by anything either. So what we're going to do, we'll multiply the top equation by 5, and we'll multiply the bottom equation by 3. And then the top equation will have a 15x term. The bottom will have negative 15x as its x term. And when we add the equations together, the x term will disappear. It'll be 15x plus negative 15x, so you'll have 0x. So we have a negative 5x on the bottom, so we multiply the top one by 5, and we have a 3x on top, so we multiply the bottom one by 3. Okay, so and the signs have to work out. The bottom x term was negative, so we don't have to multiply by a negative, right? It's already negative, so we make both of our numbers positive, and that's going to work. That is, both of the multipliers are positive. So we'll just write both equations over here. The top equation becomes 15x minus 35y and then that equals 60. The bottom equation becomes negative 15x, and then you take the 3 times negative 4y, that's negative 12y. 3 times negative 20 is negative 60. So now we add the equations together, and the x's go away. 15x plus negative 15x is 0x. In the middle we have negative 47y, and over here we have 0. So y is 0, right? Divide both sides by negative 47, and on the left you get y, and on the right, 0 divided by negative 47 is, of course, 0. So now we just take that, we plug it into one of the equations, either one. We'll use the top one, 3 times x minus 7 times y. Y is 0, so we plug it in for y, equals 12. So that's 3x minus 7. 7 times 0 is 0, so minus 0, which we don't need to write down. 3x equals 12. Divide both sides by 3, you get x equals 4. So we have both of our coordinates now. We write the ordered pair, 4, because x is 4, 0. Okay, that's it. Okay, we'll look at one more. And there are choices we could make. There are different ways to do it. But the simplest way for this one seems to be to look at the y. We're going to get rid of the y terms. So we'll multiply the top one by 3 and the bottom one by 4, but this time one of those has to be negative, right? Because the y terms are the same sign. So we don't want them to stay the same sign because we're going to add and we want them to cancel out. So we'll make this top one negative, and then we'll write the equations, the new versions of these equations down that we get by multiplying. So negative 3 times negative 3x is 9x. Negative 3 times negative 4y is positive 12y. And negative 3 times 2 is negative 6. And then the bottom one, 4 times 8x is 32x. 4 times negative 3y is negative 12y. And 4 times 22 is 88. Now we can combine these, add them together. 9x and 32x is 41x. The y terms go away, of course, and that equals 82. So we're now going to, we'll rewrite that down here, put it closer together. 41x equals 82. Divide both sides by 41. This one comes out pretty convenient. So x equals 82 divided by 41 is 2. No big messy fraction, just 2. So we'll take that, that's our x value, plug it into either one of these equations. We might as well use the first one. So we got negative 3. We're going to plug that in for x. Minus 4 times y equals 2. And we're plugging in x of 2, of course. So now we can solve for y. Get negative 6 minus 4y equals 2. Add 6 to both sides. Negative 4y equals 8. Let's see. Add 6 to both sides, yeah. Equals 8. So now we divide both sides by negative 4. On the left we get y, and 8 divided by negative 4 is negative 2. So that's our y coordinate. We have x coordinate of 2, y coordinate of negative 2. We write down the ordered pair, 2, comma, negative 2. And that is it. So with this technique of multiplying both equations by the necessary number, we can do this for any system now, right? We don't have to wait on a system that happens to be just right. We can solve any system of two equations with this method, now that we realize we can multiply both equations by the necessary number to make one of the variables go away. So that's all. You'll have a homework assignment that has some problems like this. See you later.